Hello again to this training workshop series on the Eclipse Arrowhead framework. In video 9, we will discuss the rules for intercloud interactions and how to set up service discovery across multiple clouds. So let's go to the link again in the Arrowhead GitHub repository for setting up the ActiveMQ server. So in the previous video, we already set up the installed and configured the ActiveMQ server both in the insecure and secure mode. Now we can see that how to start using the ActiveMQ server and set up the Arrowhead gatekeeper and gateway core systems. So we can open the application properties of the orchestrator core system, which is located beside Arrowhead orchestrator Java in the orchestrator folder if you have used Debian installer. Find the property named gatekeeper is present and set to true. And save the file, restart the orchestrator core system like that. So once we have the ActiveMQ server gatekeeper system running and the gateway system running, we need to set up this property as true in the orchestrator application properties to make it work. If you have used the Debian installer to install the core system, then we need to do these things as well. So if you have configured FTMQ server before as secure in secure mode before, there is one step you must take before starting the gatekeeper and the gateway systems. You have to append the relay master certificate to the trust store of this core system. So let's say if we have the two local clouds, one is test cloud local 1 and test cloud local cloud 2. Those are the names of the local clouds. So we can see that we have to do this step as well. After this last step, you can start the Arrowhead gatekeeper and gateway systems. If the installer Arrowhead system, these are the two basically. This is how it shows that they are running. So the next step is to add the relay. A local cloud must know about the relay before using it. So you have to register the relay into the cloud database. So the relay is basically the ActiveMQ server. So and we need to add this inside the gatekeeper to that the IP address of the ActiveMQ server, its port number, general relay, it's if it's secure or not secure, and exclusive is always false. So we can do that in the Swagger of the gatekeeper system. And then we need to add the neighboring clouds. Arrowhead clouds must know each other if they want to communicate. So the next task is to register test cloud 2 to test cloud 1 database and as a neighboring cloud and vice versa. To do this, we need the text representation of the public key of the test cloud 2 gatekeeper, also known as authorization info. So this we need to add into the database of the Arrowhead local cloud. So we can acquire the public key of the authorization info of an, so we need the public key of the test cloud to gatekeeper in the PM format. In real life, you have to contact of course them, but in this environment, we can get it from gatekeeper.p12. So if you open that up into the the key tool program comes with the Java 11. If you don't have, then so here it looks like we can see the public key from here, from the key tool. But here is an important step that we don't need the begin and end the public key as well as we need all the information in one single line. So we need to copy paste that information. So registering the neighbor cloud 2, you can use the gatekeeper Swagger interface of the test cloud 2, 1 to register test cloud 2 or otherwise. In a browser, open the gatekeeper Swagger API, select the gatekeeper management relays, get request and call it without any parameters. And then this will be available in the something like this. So the important thing here is the ID of the relay we register. Before one in our example, this is next the gatekeeper management is clouds in the post server. The input JSON is like this. So here comes the authorization of from the previous step. This one, this key, public key, and we have to repeat the same steps for the gatekeeper of the neighboring cloud as well for the test cloud too. And this way, they now both the gatekeepers of the local clouds, they know each other. They know the relays, ActiveMQ server IP address, and they know how to find it. And the ActiveMQ server basically provides all the relevant information and authorization uh, to perform it interact with these for the interaction of these local clouds. So yeah, that's it. Thank you very much.